Thank you very much for coming and for letting me share with you something about this experience, which was a collaboration between us at Bibliotheca Alexandrina, the Library of Alexandria in Alexandria, Egypt, and a group of students from our very active summer internship program, students from the Alamein International University. It's a newly established university in Alamein. That might sound familiar to those of you interested in history. It was the site of a very famous World War II battle. It's about 100 and something kilometers west of Alexandria. So under this topic, I worked with Amr, Khaled, and Shaden, students from Alamein University. Thank you very much to them for their work. And we explored the idea of news. Okay. So when we started looking at news on the web as a data set, we quickly realized it has some special significance. We can quickly say 4 things. It's a very common activity in society today. It predominantly happens online. News media was very early on to adopt the web as technology, and it has increasing value over time. So there are various studies and research that we can look at, but for example, here the Global Web Index tells us that it's a very regular activity, and it's even a primary reason why many people use the internet today to get their news. There is this study from Reuters, the Digital News Report 2024, which tells us that today online news channels are the primary source for news for people wherever there is internet. We can make a table of popular news websites, and we can see that many of them started sometime in 1995, 1996, maybe a year or two later. And simply put, when we think about it, news, current events today, as time progresses, they grow into history. They become history content. So there is value in news. So let's look specifically at news in the Web Archive as a form of as data set. There are, of course, many efforts to look at news and analyze news. For example, there is GDELT, the global database of events, tone and language, language and tone, and there are others. GDELT focuses on real-time news monitoring. But what about the Web Archive? Can we make the data in the Web Archive, the news content, more accessible, more usable for researchers? So we thought there is a good opportunity to do something good and help people who need this data make better use of it. If we analyze the data for them, which takes heavy computation, as we will see, we can then offer that data as a derivative data set of derived attributes from the original records, and maybe also provide an interface for querying and visualization. This was the plan for our project, very simple, very basic. There is data in the WARC files. We take that data, run it through an analyzer, and then produce derived attributes, store that in a data store, a database, and which then can be queried and visualized using a viewer. So let's look at each part. So the first part is the analyzer. The analyzer does the usual of iterating over WARC files, doing pre-processing, removing a lot of noise, and then passing that to the analysis step itself. And that's where we use NLP to run different tasks on the data and produce attributes, such as sentiment analysis, categorization, etc. We can then store that in a database, and we notice that the output size here is significantly smaller, way smaller than the input. So that the output data is actually quite light. I went back. Okay. So here, this is where we use NLP, and there's obviously today an abundance of models and techniques that are now quite easy to use inside your Python programs to extract information from text or to derive attributes from text, such as sentiment analysis, categorization, named entity recognition. A lot of them use machine learning, but some of them are less complicated. They are just statistical, plain statistical. Some of them are more direct than others. For example, if we try to do something like fact versus opinion classification, that would require further steps than simply to run a model or use the ready library. The derived attributes we store in a data store. Currently, it's just SQL, but we can expect that as the data becomes larger, as we process many, many more WARC files, this can grow, and we might need something different. Yeah, and then let's look at the viewer. We developed a viewer, a simple viewer, to look at our data. It uses the pre-analyzed attributes that are now stored in the data store to visualize and query the data. We used Streamlit for data-driven UI. It makes writing code simpler. Okay. So yeah, this is an example of how we can query based on, we can select time range and limit the results to certain categories, such as health news, for example, and ask it to give us a visualization, such as this plot. So we can look at how sentiment of articles have changed over a period of time. That's the color tone with the confidence score of that analysis over a period of time. Of course, there are many different things we can also do. Let's put this, now that we have code, let's put it to the test. So we went to find a big data set to work on. And there is, of course, Common Crawl. Common Crawl has a news data set that they published since 2016. Yeah, here's a blog post by Sebastian, who's here at the conference. We took that data set, but there's also other data sets that we can use. For example, the IIPC collection development group makes very good Web Archive collections, including a news collection. And if we think about it, any Web Archive collection is bound to have some news content within it. So this is a summary of the Common Crawl news collection. It started in 2016. So what we did, we tried to benchmark how this would perform on different hardware configurations, specifically GPUs, which are the engine that the accelerators that all of that machine learning stuff happens on. For that, we use the cloud provider. We have our own GPUs. We have a high-performance computing service that we provide to researchers at the Library of Alexandria, but that's mostly busy for scientific computation and the research that happens at the universities. So we had some extra budget to use on one of the cloud providers, and that's what we did. So we compared this on 5 of NVIDIA's GPUs, and in conclusion, the best performer processed each WARC in about 40 minutes. But let's look at more details. So this is our comparison. We ran it on a set of WARC files, and for each one we recorded the time. The 5 GPUs were the M60, V100, T4, A100, and H100, one of their best, latest GPUs. And we see there is obviously a difference. And here I put the cost per month, but that's in relative units, so it's not actual units. With the most expensive one, obviously the H100 from 2022, costing 100 units, and we can see there is obviously quite a big difference in cost. So this kind of processing is inference. We're not training models here. I would say it's clear that the T4 is the most economical, although it adds 1 hour of processing time per work. This is the plot of how they look like. Again, obviously, the H100 has an advantage, but the T4, which is much less expensive, is also doing not bad. So if we were to process the common crawl news collection to make it more accessible, more usable for researchers with pre-analyzed attributes attached to it, extra metadata that we can put maybe in a WAT file, and WAT files and share with researchers, it would take 3 years and a quarter on a single H100. That's obviously a lot. And if we go with a T4, that doubles or even more than doubles that time. But with collaboration or parallelization, we can do a lot better. So this is just one idea we put out. This is a web form where people who would like to take the code and run this processing on their hardware, they can contribute the attributes file. And then we can perhaps collaborate to make this actually happen. So to summarize, I would say there are 3 takeaways that we have out of this work in news content on the web as a data set. So first, there's a good opportunity to process that data. There's value in making it more usable to researchers who will not necessarily have this computation or maybe a technical skill to do this initial analysis to extract attributes such as sentiment entities and so on. We can share that with the researchers and add value to that collection. Another thing is the problem is computationally intensive, obviously, but it's approachable with collaboration. So it's also maybe an opportunity for us as community to work together. And finally, since we did this as an internship project, we found that the code is actually a good example for how developers can use web archive data and make cool projects. So maybe we will use it again as a tutorial or hands-on demonstration of how you can use web archives and process data. If you have any thoughts or questions, please, if there's time, you can share them now or later, anytime. Thank you very much.